Welcome to part one of our image counter case study. In this first part of the lesson, we'll look at the structure and the functionality of a program that crawls a hierarchical folder structure recursively, starting at some designated root. It's basically implementing a form of a web crawler. We'll also talk about various project reactor operators that can be applied in this case study, some of which we've seen before, some of which are new. So again, this case study will be used to do a crawl of a hierarchy of folders recursively. As you can see, there's an entry point, which is the root of the hierarchy, and the hierarchy contains both subfolders as well as various files or contents, which could be images or HTML documents or whatever you'd like to store in the file structure. The purpose of this particular image counter program, as the name implies, is to count the number of images on each page. And note that the folder structure that we're traversing can either reside locally, in other words, in the local file system of the local computer, or it could be accessed remotely, in other words, by making HTTP requests and accessing it through the web. Here's some printout diagnostics that occur when you run the program on the example that comes built in, what was used for testing. As you can see here, this program detects whether we've already tried to traverse a link before, and if so, it just ignores it. We don't want to do any double counting. It also has a way of being able to detect whether or not we've exceeded some max depth, which is a way of being able to kind of prune the amount of traversal if you have a very, very deep web hierarchy, or if you have recursive links that point back to each other in ways that would cause cycles. If you haven't exceeded the maximum depth, or you haven't already seen the image folders before, or the images before, or any content before, what it'll do is it'll find the number of images at each level and then print that. And it essentially bubbles that information up. So by the time you get back to the root level, it'll give you a cumulative count of the total number of images that are available from that root. So let's talk a little bit about how the program is designed. The image counter class has about a half dozen methods that perform the recursive traversal. You can see the source code at the link at the bottom of the slide. The methods in this class use many project reactor operators. For example, there's a bunch of mono operators, some of which we've talked about, some of which we haven't. So the ones we're going to talk about here, we're going to talk a bit more about default if empty and transform deferred. We've looked at the other ones before. Likewise, there's a handful of flux operators that are used. This is more of a mono style processing app than a flux app, but we do use both of them in here. We've seen all the flux operators before, however, so we won't go into them in any more detail before we start looking at the code. So let's start by taking a look at one of the mono operators we haven't talked about before, and that's called default if empty. And what it does is it returns a default value if the mono is completed without emitting any data. If that happens, if the mono does not emit any data, then the default value that's passed as a parameter is in fact returned as the result of that operator. So what it does is it returns a new mono that either will emit the value that was emitted by the mono if there was something to emit, or it'll emit the default if no other value was emitted. This operator is commonly used after other combining operators that return empty results. Examples of that would be things like reduce or collect list. Here's an example that we'll talk about when we get into the source code. I'll just give you the short summary right now. So this particular part of our image counter case study is going to take a page, a web page, and it's going to look for all the hrefs or hyperlinks that are embedded in that page. And if it finds them, then it'll do recursive traversals of those hrefs and count how many images are found during that recursion. When it gets back with all the recursive traversals, it will then do a reduce operator to sum all the results up. However, if there are no hrefs on that page, if there are no hyperlinks on an HTML page, then there won't be anything to traverse, and reduce will return an empty mono. Therefore, if we get an empty mono back, we're going to use the default if empty operator to return 0, which is exactly what we would want to do in this case. This default if empty operator is very similar to the Java optional or else method, although Java optional is not quite as asynchronous as monos are, but it plays a very similar purpose in both technology platforms. The next operator we're going to take a look at is the schedulers from executor operator. And this is used to create a scheduler that uses a backing executor to schedule runnables for async operators. The exec parameter that's passed in from executor can be the common fork join pool. It can be any of the other executor implementations that come out of the box, like fixed size thread pool or cache thread pool. And of course, you could also define instances of, say, thread pool executor that had different parameters than we get out of the box, or you could even implement your own executor as long as it conforms to the executor interface and use that as a parameter here. Here's a simple example we'll take a look at in more detail when we get into the source code in the image counter example. This is a method in a helper class called reactor utils called common pool mono. And it uses the subscribe on operator on a mono in order to be able to schedule the mono to run on the common fork join pool. And it does this by using schedulers.fromExecutor and then passing as a parameter the common pool from fork join pool. So it gives back the one and only instance, and that's what's used to do the processing. The third method we're going to take a look at is the transform deferred operator. And this is a very interesting operator. It's a little confusing at first, but it's very powerful. And it's used to defer the transformation of a mono such that it will generate a target monotype. And the way it does this is it takes a function parameter using the function functional interface that's defined in modern Java. And it uses this to lazily map the mono onto a target publisher instance. So let's take a look and see how this is used. I think it'll make more sense when you see it used in practice. The purpose of this operator, the transform deferred, is to define custom operators that can be used in a mono pipeline or a chain of mono calls. So here's an example we'll also take a look at later. This method is used to get the HTML contents at a given URI, and it's going to do it in a background thread coming from the common fork join pool. So the from callable is going to go ahead and essentially use the JSoup library to go out and grab the appropriate contents. And we're going to use transform deferred and tell it to run that computation in the common fork join pool, which is what we get back when we call reactorutils.commonPoolMono. And so you can see how this is a way of kind of making your own custom operator to run things in the background. If you take a look at the implementation of how this works, it's basically implementing the decorator pattern. And that's a gang of four pattern that can be used to add behavior to an object dynamically, in other words, at runtime. The way this works internally is that the transformations will occur for each different subscriber. So if you have multiple subscribers, you can actually get different behaviors depending on how you program your use of what's passed to transform deferred. For example, an operator can produce a different operator chain for each subscription that's given to it. And it can do this by maintaining state or using some conditional expression. Here's a simple example to illustrate the point. There's, of course, other ways to do this as well. This particular example is a slight modification of what we just looked at, where we're going to use yet another helper method called common pool mono if. And the if indicates it takes a predicate, and the predicate is either true or false. And if it's true, it says use the common pool. And if it's false, it says just do everything sequentially. So it's going to allow some conditional decisions at runtime about what path to go. Here's the implementation of the common pool mono if operator or method, helper method. It takes in the Boolean para, which stands for parallel. And if para is true, then we're going to return the reactor utils common pool mono. Otherwise, if it's false, we just return the mono. So what that says is do concurrent processing if para is true. Otherwise, use sequential processing. There's a similar method that's defined in RxJava called compose. Works essentially the same way. Once again, I'm not quite sure why they call them two different things, but they both allow for creating custom operators that essentially extend the behavior that's possible to have with chains of methods with either monos or fluxes. So that's the end of our overview of some of the new operators we're going to cover and the image counter case study. Now let's go ahead and take a look at the source code.